Now let's see how our iterative post-order traversal works on the tree that we have been looking at for all our examples. Okay, so this is the tree that we are talking about. Okay, so let's start our post-order traversal on this particular tree with call to post iterative. And we mean the address of node 10. Okay, so I start with 10 and I start executing the function. Is my node null? It's not. So what I'll do is I'll create two stacks, S and O. So let's create these stacks. So first is the stack S, and then let's have a stack O, which is output. Okay, so we created these empty stacks and then we are going to push our root node. Okay, so now 10 goes onto this particular stack, and now we start executing this while loop. So is our stack S empty? It is not empty, so I'm going to pop something from the stack. So now I'll keep track of my variable current. Currently it is 10, and then what is going to happen? I'm going to say that my current is 10, and to my output stack I'm going to push the value in this node. So output will have 10, and then I'll check if my current dot left is null. So if I go back to my tree, 10 dot left, is it null? It's not. It is 20. So now what I'm going to do is, this 10 was gone. What I'm going to do is I'm going to push 20, okay, or the address of node containing 20, and then I'll check if 10 dot right is null. It's not. It is 30. So I'm going to push 30 onto the stack. Okay, and then I have reached to the end of while loop. I'll go to the beginning. I'll check if my S is empty. It is not empty. So I'm going to pop an element, so I'll get 30. So my current becomes 30, and for 30, first thing that I'm going to do is I'm going to push it to the output stack. So I'll have 30 here, and then let's proceed further and check if 30 has any left subtree. So it has subtree with 40, so I'm going to push 40, and then let's ask question, do I have a right subtree? Okay, so there is no right subtree for 30 here, so nothing to push for this, and I reach to the end of the loop. I go back to the beginning, ask question, is my stack S empty? It is not. Then I have to pop a value, and I forgot to write that I pushed 40, right, for the left subtree. So let me write 40 here. So I will pop a value from the stack, which is 40. So I'll get 40 here, and the first thing that I'm going to do is I'll push 40 onto the output stack. So it seems like I had written 40 by mistake to the output stack before, instead of writing it to the S stack. Okay, but now our mistake is corrected. So now our current is 40, and we ask question if our 40 has a left subtree. It does have, so I'm going to push the left child of 40 to the stack, which is 70. So it goes to S. This time I'm writing it to the correct stack. And then what do we need to do next? We have to check if it has right subtree. 40 doesn't have a right subtree. Look in this tree, it has only left subtree. So now what we'll do is we'll reach to the end of the loop. We come back, ask question, is our S empty? It's not. So what we'll do is we'll pop an element, and now my current will become 70. First thing to do is add it to the output stack. uh, and once we do that, 70 is gone. Once we do that, the next thing to do is that check if 70 has a left subtree, right subtree, both of them are absent. So I will reach to the end of my loop and come back to the beginning. Ask question, is my stack empty? My stack is not empty, there is still 20 in there. So what should I do in that case? In that case I should pop it. So now 20 is gone and my current becomes 20. And then the question to ask is, oh, does my current node have a left subtree? 20 has 60 as left subtree. So what will I do is I'll push 60 onto the stack. So here I don't have space, so I'll just write 60 here, but it is the last element inside my stack. Okay, and then I have to push the right. So the right of 20 is 50. So I will write 50 as the next element onto the stack, and then I reach to the end of this loop. I go back to the beginning. I ask question, is my stack empty? It's not. So I pop an element. So 50 comes out, and now my current becomes 50. And I forgot to write 20 in the output, right? Yes, that was my mistake. Okay. So now 50 comes out. The first thing that you have to do is write 50 to the output stack. Once you do that, you ask question if 50 has a left subtree. It doesn't. That's the way our tree is. And then does 50 have a right subtree? It doesn't. So you reach to the end of the while loop. You go back and ask question, is my stack empty? It's not. You pop 60. Your current becomes 60. You copy 60 to the output stack. 60 doesn't have left subtree, right subtree. So you come to the end of your while loop, and now you observe that your stack S is empty. So you break out of the loop, and now you come to your output loop, and now you keep on popping the entries from your output stack. So now your output is going to be 60, 50, 20, 70, 40, 30, 10. Okay, so that's your post order traversal, and let's compare it against our recursive post order traversal. Are we getting the exact same output? Okay, so here is the output for our recursive post order traversal: 60, 50, 20, 70, 40, 30, and 10. So we got identical output, but the difference in the logic is that we are not using recursion. Instead of that, we are using two stacks. Okay, so it is still possible to do the iterative post order traversal while using a single stack, but I'll leave that as homework to you. If you face problem in it, please ask me during our interaction session on Mondays.